Hey guys, how are you doing today? We're gonna talk about the complex conjugate root theorem, okay? It's pretty simple and it's pretty cool, so let's dive into it. So this theorem, it's about the complex roots for a polynomial. So let's suppose we have the following form. If we have a times x squared plus bx plus c is equal to 0, this is a quadratic equation in a pretty common form. Now what are the roots or the points or the x-intercepts, you could call it, for this equation? Now in this case we know we could use the quadratic formula, but what if we knew that there were complex solutions? Basically, if we define a polynomial that has this equation, so if we say p of x is equal to the thing that we have on top, now we could say from here that if and only if p of a plus vi, remember this is a complex number in the form a plus vi. You have a real part and a complex part or imaginary part. Now if the polynomial evaluated at this complex number is equal to 0, then the conjugate, of course, of this number is also a root for this polynomial. A minus vi is also going to be equal to 0, okay? This is only true when you know that one of the roots that you have is a complex number in the following form, okay? So now let me show you an example of, well, how you would apply this to a problem. So let's suppose we have this pretty good looking equation. Now it has, well, a coefficient of 1 in the squared term. It also has not so large coefficients. It's pretty cool to deal with equations like this. But now I want to show you that this, well, you could say not so hard equation, it's actually got complex roots. And we can apply the complex conjugate root theorem to find, or well, to show you that how, well, I know, actually it's the other way around. We can use this problem to show you how the conjugate, the complex conjugate root theorem is actually true, okay? So now, what are the solutions to this equation? We're going to use our quadratic equation. So we know it's going to be minus b plus or minus square root of b squared minus 4ac divided twice the first coefficient to a, okay? Now, we need to substitute our values. So we're going to have that x is going to be minus b, so minus 2 plus or minus square root of b squared, that is 4, minus 4ac, 4 times 1, 4, times 5 minus 20. Now you guys see what is going on there, right? And you get 2 times 1, it's simply going to be 2. Now in this case, we're going to get a square root of negative 16. Now this is, of course, a point in which we have to use complex numbers. So if you don't know how to find the square root of a negative number, just go and check one of my other videos. You should find it very easily. So now we can distribute this term or this denominator into both of our terms. So in this case, we would have negative 2 divided 2, that is just going to be negative 1 plus or minus. Now square root of negative 16. Now here comes the fun. Now what is the square root of negative 16? Now if you don't know how to find this square root, you could do some plugging and checking in, okay? So plug in and check if that value works. So for example, you could say that, well, this is just simply the square root of 4 the square root of 16, and then multiply something so that you can get negative 1. Now this is going to be just simply 4i, because if you square 4i, you're just simply going to get 16 times the square root of negative 1 squared. We know we can cancel out the radical and the square, and we're going to get, this is just simply 16 times negative 1, which is what we have inside the radical. So this, we can simplify it into x is going to be equal to minus 1 plus or minus 4i, okay? And now this is in the form a plus or minus, you could have also bi, okay? And this satisfies the complex conjugate root theorem, because we know that if we plug in this value for this equation, we would get 0. And also, well, we can plug in positive, so we can say minus, we could say that if we define that as p, so let me say right here, this is just going to be p of x. So we could say here that we've got p of minus 1 plus 4i is the same thing as if we had p of negative 1 minus 4i. Because both of these guys, well, they're just going to give me 0, okay? Because that is the solution to this quadratic equation. So this is one of the problems that, well, it can show you how you can intuitively see in this part, because you've got a positive or negative for the square root, how the complex conjugate root theorem is actually correct. And well, it's going to give you some intuition into some more problems with complex roots, okay? So I hope you guys enjoyed this video and see you in the following one.